Hi students, in this video we are going to see a small topic but important topic. The topic name is dipole in a uniform electric field. Usually carries 2 mark question. Okay. So to start the topic we want to write something that is about what we are going to do now. So we will start like this one. Let a dipole be held in a uniform electric field. So after writing this we want to draw a uniform electric field. You know what is uniform electric field, right? They are parallel lines. So we will write that one. First the statement we will complete. Then after that we will draw the diagram. So let a dipole held in a uniform external electric field E at an angle theta with the uniform electric field or direction of uniform electric field. Okay. We will go slowly because as I said before, few students said like it will be good if you can reduce the speed of talking. Okay. So I am drawing the uniform electric field now. You know that uniform electric field is parallel line. So let me do some parallel line. These are representing the uniform electric field, and also you can give the label of the uniform electric field capital letter E. Okay. Next the topic is dipole, right? Dipole meaning is two charges. One is positive charge, so plus q e we can keep, plus q we can keep one side, minus q we can keep other side. And you know that distance between the charges, it is usually representing with 2a. Okay. And we want to mark the angle, actually what angle the dipole made with the uniform electric field, that will mark theta. And also the force acting on the charge placed in a uniform electric field, the value is QE, right? Because we wrote before E is equal to F by Q. So F is equal to QE, Q into E. So on charge plus Q, QE is there. On charge minus Q, minus QE is there. And angle between the dipole axis and the electric field is E. We want to get this perpendicular distance when we apply in the derivation. Okay. Perpendicular distance, you can see the dotted line is there. To get that one, consider there is a triangle formed with theta and 2a as the hypotenuse. So sin theta is equal to opposite side divided by hypotenuse. Here the opposite side is the side we want to write later, divided by hypotenuse. Here is the length of the dipole in this case. Okay, that is 2e. Okay. So sin theta is equal to opposite side divided by 2a. 2a is the length of the dipole, that cross multiplying to left side. So when we are cross multiplying that to left side, our opposite side value will be 2a sin theta. Okay, keep it safe, we need it later. Okay. Now we will start about the remaining part of the derivation, that is how much torque will be acting, that one. Before that one, you know that the force acting on each charge plus QE minus QE, right? So the net force on the dipole is equal to 0. Why? Because they are equal force, opposite directional force. So the net value is equal to 0. But still there is a chance of producing torque. You know the topic torque, right? We will write the expression after this. First we write what are the things to write. The forces on the charge plus Q and minus Q resulting a torque on the dipole. Okay. Because when there is a torque, definitely there will be a perpendicular force and a distance between the force applied and the axis of rotation. Okay. So one more time, the force on the charge plus Q and minus Q resulting a torque on the dipole which rotates the dipole. Thus the torque tends to align the dipole axis along the direction of the electric field. Okay, what is going to say now? Because of the torque acting on the dipole, this dipole will try to turn and will come parallel to the axis of the electric field. So the magnitude of the torque is equal to equation for torque I am going to say. The magnitude of the torque is equal to the magnitude of each force, okay, magnitude of each force, you know the force is QE, okay, not QU, QE multiplied by perpendicular distance between the forces, okay, done, QE, done. Now we are going to write the expression for it, expression for the torque. Anybody remember the symbol used to represent the torque? A special symbol, right? A special symbol means tau, it is tau, okay. So let me finish this. Torque is equal to, that is torque symbol is tau, is equal to force into distance, or exactly it is perpendicular distance we can say, okay, perpendicular distance, equation for torque. Look into the diagram and identify what is the force here. There are two forces, you just need any one force and magnitude only required, so no need to look into plus QE or minus QE, write modulus symbol or just write directly QE. Q is the force, okay, Q is the force. And the perpendicular distance we worked before, you can see below the diagram, and we found it is 2a sin theta, yeah, 2a sin theta. So torque is equal to QE into 2a sin theta, done. What is the next step is, we do a small movement of the variables. The purpose of the moment is to identify the dipole moment from here. So Q2a E sin theta, all variables are still there, okay. QE 2a sin theta, total 5 variables were there, now also there. Why we wrote like this one? Because Q into 2a, that's a special term, that is a special term. What is the name of the term is electric dipole moment. So we can write like this one. We know that electric dipole moment, you know the symbol P it is, okay. Electric dipole moment P is equal to Q2a. So the above equation for torque we can rewrite. Torque is equal to, in the place of Q2a we can write P E sin theta. That's all. This much simple it is. Okay, the topic almost finished now. Torque is equal to P E sin theta. This is in scalar form actually. If you see the term like sin theta, cos theta, you understand that is a scalar term. Vector term will be like this one. Each variable will be presented in vector. That is above the letter there will be an arrow mark and a cross symbol between them. So torque is equal to P cross E. Okay. This is the topic. So simple topic, right? Just weightage of 2 mark you will get it for this one. Okay. A 2 mark weightage it is. Now the direction. That also we want to know which direction the torque will be acting. So the direction of the tau or torque is given by, there are too many rules you studied in grade 10, you remember? Right hand thumb rule is there, then Fleming's left hand rule is there, Fleming's right hand rule is there, right handed screw rule is there. That is how a screw go into the wall, that one, that direction. So right handed screw rule. Okay, we will get the direction of the torque using right handed screw rule, and it is perpendicular to the quantities. It is perpendicular. If you look into diagram again, refer the diagram again, you will understand how will be the direction of electric field, that is towards right up as per that direction, right. So this will be, the torque will be perpendicular to dipole moment as well as the electric field. How is this topic? Is it okay? Understandable? If not understood, just reply again, easily you will catch it. Okay students, thank you, have a nice day, bye bye.